Hi everyone, today we are going to talk about how to solve equations that involve algebraic fractions. So before we start, let's talk about a more simple equation. Remember, an equation has an equal sign, so these problems now should be able to be solved for an actual answer of x equals a number. So let's take a look at this equation that's a little easier to solve. So if we had 3x over or divided by x plus 2 equals 2, you probably recall when we worked with problems that had fractions, we usually took that denominator and we multiplied by the entire equation by that denominator so that we could cancel stuff out. Okay, so if we were to then put parentheses around this entire equation and multiply it by the binomial x plus 2, which was the denominator here, let's see what happens when we distribute that binomial. So I would end up with still 3x over x plus 2, but now remember it's being multiplied by x plus 2, and x plus 2, it will help for us to put that over 1 so that we know it's actually on the top here. Okay, so that's what happens when we multiply x plus 2 times the term on the left-hand side of the equal sign. We also have to multiply it by the 2 that's on the right-hand side. Keep it in parentheses so that each term gets multiplied later. Okay, so far that's what we got when we multiply the entire equation by x plus 2. Now let's see what happens. These x plus 2's cancel each other out on the left-hand side because one's on top, one's on the bottom. Anything divided by itself is equal to 1. Okay, so when we say it cancels out, it doesn't disappear, it just becomes times 1, and which doesn't really change the 3x. So it just becomes 3x that's left over on the left-hand side. We like that. And then on the right-hand side, this 2 is being multiplied by the x plus 2. We have to make sure it's in parentheses so that it gets distributed. So we get 2x plus 4. And look at that, we just changed that mess of an equation with that denominator to just 3x equals 2x plus 4. Then we can solve this equation like normal. We're going to subtract 2x on both sides. So we get all the x's on the left-hand side. 3x minus 2x is just 1x equals 4 left over. So my answer is x equals 4. If I were to check my answer by plugging it back into the equation, it would become 3 times, instead of x, 3 times 4 over 4 plus 2 instead of x plus 2 equals 2. 3 times 4 is 12. 12 divided by 6 is equal to 2. So that actually works out. Okay, so we're going to take a look at some other examples, but we're going to follow that same strategy of taking our denominator. It does look like a binomial now, or has multiple terms, but we're going to do the same thing as we've done before, which is to multiply that entire equation by that denominator so that we can get rid of it. So we're going to make it complicated before we make it simple. Let's try example 8 from the book. Solve the fractional equation 2x plus 1 divided by 3x plus 4 equals x divided by 3x minus 2. Go ahead and pause the video and try it on your own first. Okay, so let's take a look. We have 2x plus 1 over 3x plus 4 equals x over 3x minus 2. We have two different denominators that we want to get rid of. So let's do that. Let's actually multiply the entire equation by both of them. We're going to multiply by 3x plus 4 times 3x minus 2, both of them together. Okay, So at the end, let's just rewrite what happens. On the left-hand side, 2x plus 1 will be multiplied, and remember when you multiply, it's on the numerator, by 3x plus 4 times 3x minus 2, all over 3x plus 4. Okay? We'll simplify later. And then on the right-hand side, we have x times 3x plus 4 times 3x minus 2 over 3x minus 2. Okay, so I end up actually being able to, now these are all related through multiplication, so I can just cross stuff out to reduce. I have a 3x plus 4 on top and bottom. I can cancel that out. And over here, I have a 3x minus 2 on top and bottom. I can cancel that out. So this becomes 2x plus 1 times 3x minus 2 equals x times 3x plus 4. So I got rid of my denominators. And essentially, by multiplying the denominator, the same denominator by the same numerator, I got rid of that. But then I do have to tag along my 3x minus 2 as well, because it also needs to multiply by the entire equation. Okay, so if you're looking for a shortcut, you can just rewrite the left-hand side without the denominator now, but with the other factor that provided the canceling on the other side. If not, you can just write this out to make sure you don't make any mistakes. Okay, I still have to solve this problem though. So let's go ahead and multiply this out. I have on the left-hand side 6x squared plus 3x minus 4x minus 2 when I multiply that out. And then on the right-hand side, I have 3x squared plus 4x. All right, and I need to do some simplifying here. I'm actually going to go ahead and erase some of this on the top so I have some room. So I'm going to rewrite this on top. 6x squared plus 3x minus 4x minus 2 equals 3x squared plus 4x. Okay, and then I'm going to set it up like a quadratic equation where I have my quadratic expression equal to 0. Okay, so I'm going to subtract, make it into a pen again. Subtract 3x squared here and here. I'm going to subtract 4x from this side as well when I'm done. Okay, so I'm going to move all that stuff over. So I end up with 3x squared. This combines to minus 1x minus 2 equals 4x. So I still need to subtract 4x from both sides. So I'm basically just moving everything over to the left-hand side so that I end up with just my quadratic expression equal to 0. And then I still have to factor it. So I'm looking for two numbers that can multiply to get to negative 6, my a times c, 3 times negative 2, and add to negative 5. Let's see, 3 and 2 could work to multiply to get to negative 6 and add to negative 5. They would both have to be, no, maybe it's 6 and 1. Because one would have to be negative, one would have to be positive. So 6 and 1, yep, there we go. Negative 6 times positive 1 is negative 6. Negative 6 plus 1 is negative 5. Okay. So I end up with 3x squared minus 6x plus a 1x to get to my answer, and then a negative 2. Okay, so these both have in common a 3 and an x, and then these both have in common an x. These both have in common a negative 2. So I should have 3x plus 1 times x minus 2 using the diamond box method. Let me just mentally check that. 3x squared minus 6x plus x negative. Yep, it works. Okay, and remember we have to set each of these equal to 0. Okay, so I end up with x equals negative 1 over 3, and x equals 2 as my answers. That's how you solve a fractional equation. So all the stuff that you've done before, but you first have to get rid of the fractions. All right, let's try another problem. Solve the equation 2 divided by x minus 2 plus x minus 3 divided by x minus 4 equals 2. Here, we're going to do the same thing. We're going to multiply the entire equation by x minus 2 and x minus 4. Go ahead and pause the video and try it on your own first. Okay, so we're going to multiply by both of our denominators. So you're going to end up with 2 times x minus 2 on top times x minus 4, because remember those are technically over 1. And then your denominator still stays x minus 2. That's going to end up canceling later. Plus, this is x minus 3 times x minus 2 times x minus 4 over x minus 4. That's going to cancel. Equals 2. This 2 also had to multiply by x minus 2 and x minus 4. Running out of room here, but you get my point. See if I can squeeze that in. X minus 4. Okay. So then at the end, I get 2 times x minus 4 plus x minus 3 times x minus 2 equals 2 times x minus 2 times x minus 4, after we simplify, since some of these terms got canceled. Okay, now that you're here, you then can actually distribute, multiply, all that good stuff. Okay, so these guys need to be multiplied together. This needs to be multiplied as well. Well, actually, for the right-hand side, I would multiply my binomials first and then double it. Let's get to it. So then this becomes 2x minus 8 plus, I gotta use FOIL and multiply these together, x squared minus 3x minus 2x plus 6, because it's negative and negative, equals 2 times my x squared, because I gotta multiply these two first, minus 2x minus 4x plus 8. Okay, now let me simplify. So I have x squared all alone, okay, and then let me combine all my x's. 2 minus 3 is negative 1. Negative 1 minus 2 is negative 3x, and then my 6 minus 8 is negative 2 equals, 2 times, this is x squared minus 6x plus 8. So I still have to double that. Minus 12x plus 16. And this side's already simplified. Okay, so we're not done yet. So far, you have just, gotten rid of your denominators. You have simplified everything after you multiplied, and you end up with this as your answer. I'm going to rewrite it up here so I have extra room to work with. Okay, remember our last step, we still have to set it equal to 0. So move everything to one side and set it equal to 0. It doesn't matter which side. I do want to keep my x squared positive because it's going to make my factoring easier later. So I'm going to subtract x squared from the left-hand side and have it join over here. And that would mean that this minus 3x would need to also join over here. So that cancels, that cancels. I get negative 2 equals positive x squared. I moved everything to the right-hand side so that I can keep this positive. Negative 12 plus 3 is negative 9x plus 16. Still got one more term to move over, the plus 2. Now I have 0 equals x squared minus 9x plus 18. Okay, so then I have to factor. I'm looking for two numbers that multiply to get to 18, but will add or subtract to get to 9, a negative 9. I'm guessing they both have to be negative so that they can add to a negative 9, but multiply to get to a positive number. So let's see, 6 and 3, negative. Negative 3 times negative 6 is positive 18, but they add to negative 9. So I'm going to set them each equal to 0. So it's going to end up being the reverse. It's going to be positive. X is 3, positive 3, and x is positive 6. Those are my answers.